Okay, check. Can you see the slide movements or no? Okay, can you see the slide movement, students? Hello?
Yes, ma'am.
Okay, all right. So in the last class, we have studied something like the function call, that is call by address or a reference, right? So today we'll go ahead with one more best concept of the what we call it as user-defined function, that is recursion. Okay, so I'll try to write some of the programs, or at least one or two programs, using the normal method, using user-defined function and using the recursion function. So that I wanted to give the clarity between how can you write the program, right, using variety of methods in the C language. Okay, I hope I'm making it clear. And this concept, whatever I am suggesting you are teaching today, right? So if you just open your data structure in the upcoming semester, that is third semester, right? So you have these concepts in the first module. So user-defined functions, okay, structures that we are going to deal in the fifth module. So that is part of your the first module in the data structure, and recursion is the again first module. So whatever you people are learning after UDF, okay, from fourth module onwards, whatever you people are learning, all the stuffs are there in the first module of the data structure. If you study this clearly, so you are gone, you are already through the first module of the data structure of the upcoming semester, that is third semester. Okay, if you are part of the computer science, and you know you all are part of the computer science students, right? So you are through the, okay, the first module of that. Okay, I hope because little advancement will be there in the data structure first module there. Okay, but the fundas of that remains same. So whatever you people are learning here, so this becomes the base for that. So I request everybody, okay, be attentive, try to be interactive with me, okay, and learn something from it. Okay, so now look at this recursion. So recursion, so am I audible, no, students? Hello? Hello? Yeah, you can hear me, no, sir?
Yes, ma'am.
Right, okay. Yeah. So now recursion. Recursion means reoccurrence. Okay, what is reoccurring? So whatever particular function you are going to write there, so that function is going to be recalled or reoccurred. Okay, I'll write it here. Okay. Reoccurring. What is reoccurring? It's the function. So I'm going to call this function, okay, the same function. I'm not changing the function, but this function is called again and again. But who is going to call? This function is going to be called by itself. I'll repeat my statement. Okay, so this function, whatever function we are going to write, so this function is going to be called by itself. How many times? Until a particular condition is met. Until a particular condition is met. If the condition is met, I am coming out of this calling itself. Okay, I am going to come out of that particular stuff. That is what we call it as calling itself concept. Okay, when the condition is met. So this condition matters a lot for us. This condition should make me to come out of calling of itself. Okay, what is reoccurring? So reoccurring is nothing but we are going to call the same function again and again. Okay, whatever function you are going to write here, this function is going to be called again and again. But who is going to call this function again and again? The function itself. This function is going to call itself. But how many times it is going to call this function itself? So until a particular condition is met. If you don't write this condition properly, you never come out of that calling itself. I'll repeat my statement. If this condition is not written properly, then please remember calling itself, this particular concept, you never come out of this. The meaning of that is you are going to enter into an infinite loop there. Because the function is call itself again and again and again and again and again. Okay, there is no condition that is satisfied there to come out of that particular stuff. So it goes on calling itself. Right, so that's why this is very much important for the recursion. Okay, this condition. If this condition, if you are unable to write it properly, then you never come out of the recursion, or reoccurring or recalling of the same function. I hope I am making it clear to everybody. You have to have, okay, the condition, we call it as a termination condition. Termination condition. Okay, if this termination condition is not written properly, then we never come out of the loop there. Then how do I call that function? Okay, for that also we write some of the simple function for that. That function purely depends on what is the problem statement. Okay, the calling of itself, because this particular function is going to call itself, the same function it is going to call. Okay, if I write this as function, so this function is going to call itself. So to call itself, so how do I write that? So this calling itself purely depends on what is the problem statement. What is the problem that is given to you? Depending on that, we are able to write a particular function call that is going to call itself. And how many times it is going to call itself? So that particular stuff is dependent on this particular termination condition. Is it clear, student? Whatever statement I am making, is it clear, students? Please, I am again and again I am requesting. Okay. So this is very important stuff that you people are learning. Recursion makes the stuff very easy. Okay, because within 2 to 3 lines you are able to write the code. That you people, if you write the same thing using the normal user-defined function, it takes long amount of too many lines of codes. But if you write the same thing using recursion, it takes very less number of lines of codes. But the problem with this recursion is it takes maximum amount of time of the system there. Okay, the time consumption for working with the recursion by the compiler or by the operating system is too much. Time taken to execute this recursion is too much there. Okay, that is the only drawback. Other than that, this is very good concept. So is it okay, students? Is it okay? Say something. I need your response. Because I already mentioned this is very important concept that I'm dealing with. And I said also, I'll take one example or two examples. I'll try to solve it using variety of methods. Normal method, that is using whatever for loop or without functions, with recursion. But for that, your support is must for me. If you don't give good response, so I'll just take up the example as a part of recursion. Yes. What do you want me to do, students? I need your response, students. Hello? 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 Can you hear me, students? Hello? Hello? I need your response, students. Please give response back to me. Hello? Okay, it's left to you people because there is no point in talking with the dump machines. If you are acting as a machine there, so I cannot help for that. Right? Okay, so now I already told you, so you have to have the terminal condition. That terminal condition is usually termed as a trivial condition there. Right? So now, if I take simple example, that is finding a factorial of a number. Okay, this is the simplest example that help you to understand this recursion very easily. Right. Okay, then what is this? I need to have two conditions. One is the trivial condition, that is termination condition. What is that termination condition? Okay, the termination condition that I am going to write here is this. When n becomes equal to 0, Okay, if n becomes equal to 0, okay, n becomes equal to 0, I am going to return what we call it as 1. So this is acting as a termination condition or a trivial condition. Termination condition, or you can call it as trivial condition. Okay, so I said I need one more stuff for calling itself. How do I do that? So this is purely depends on the definition of the problem. What is the problem definition? Finding a factorial of a number. And this is how I am able to find the factorial of a given number. Because you already know. Okay, if I write 4 factorial here, how do I find the 4 factorial? So this is nothing but 4 into, I'll write it as 3 factorial. The same thing can be written as 4 into 3 into 2 factorial. Okay, so this is nothing but n. If I say n factorial here, this is my n into n minus 1 factorial. This is what is the meaning of that. If I write here n factorial, so this is n into n minus 1 factorial. So again, if I write here n into n minus 1 into n minus 2 factorial, right? The same thing I have written here. So this purely depends on whatever problem statement you have taken here, right? So you are going to provide the solution. So you need to know what is that problem statement, right? So this is this for the problem that we have picked up here. So n into factorial of n minus 1, n into n minus 1 factorial or factorial of n minus 1. This is what is the meaning of calling the function itself, reoccurring of the function, a recalling of the function, recalling itself. Is it okay, students? A recalling of itself is called recursion. Hello? Hello? Hello,
Yes.
students. Okay. So now this I again and how many times until a particular condition is met. What condition or a trivial condition? If this condition is met itself, coming out of the recursion over there, right? So this is very important for me. If I'm able to write the termination condition along with the function to call itself, which is purely depends on the definition of the problem statement here. Okay, I am the recursion. I hope I made it clear. I'll take up the example to talk about the same stuff. If you have any doubts, please don't hesitate to ask the questions. The example, I'm taking the same example, that is find the factorial of a number using a recursion and a non-recursion method. Okay, so before I go ahead with the non-recursion method, okay, so the user-defined function here, you already know how to find the factorial of a number. Can anybody suggest how to find the factorial of a number? Can anybody suggest me how can you write the finding the factorial number? Hello? Hello? Can anybody suggest me how can you find the factorial of a given number? Are you the students? Please give your response. Hello? Okay, so this is nothing but n into n minus 1 minus 1 into n minus 2 into and so on up to 1. So I'll be doing like this. This is how we usually find the factorial of a given number. If I write the formula, I mean the particular program for this, I'll not worry about std. I'll directly start with this particular for loop here. For I is equal to n. Okay, so I greater than or equal to 1, Okay, then I minus minus. So what I'm going to do, I'll be finding the factorial of a given number. So fact is equal to fact into I, I'll be writing. So initially this is I is n. The next time I becomes n minus 1 because it is reduced here. Okay, first initially I is equal to, if I take this as 4, okay, next time afterwards it becomes 2, afterwards it becomes 1, so finally it becomes 0. Okay, once it becomes 0, I am coming out of the for loop there. So till that time it goes on multiplying whatever n value or whatever I value I am going to have. So initially I have n is equal to, that is I is equal to 4. Next time, so that is I have a factorial as 4 there. Next time it is 3. Okay, next time it is 2 and next time it is 1. Once it becomes 0, I am coming out of the loop. So I have 4 into 3 into 2 into 1. So this gives me the factorial of a given number, that is 4. This is the simplest for loop that is helping me to find the factorial of a given number. This is using the normal way of function, right? So I am not writing any user defined function here. So now what I am going to do, I'll try to write the same program using what we call it as UDF, user defined function. Okay, so let's try to write the same thing. Okay, so now let's go ahead with the same thing now. Okay, so now look at this stdio.h. So I have to write a function. That function is helping me to find the factorial of a given number. Okay, so what I have to pass? I have to pass, okay, to this particular factorial function, I have to pass the value n. Okay, integer n I am passing and I am expecting an integer out of it. So this is nothing but the factorial of a given number, right? Okay, so I'll show the same thing now. Okay, so now look at this. This is factorial is the name of the function through to which I am passing a particular value here, integer value, to whom or I mean the value whose factorial has to be found there. Okay, that I am passing here, and after that the factorial function is going to calculate the factorial of a given the passed number here. Then it is going to return me an integer that is nothing but the factorial of a given number. Okay, so now look into the stuff now. Right, so int main. So what I have to declare here. So now I am declaring what we call it as the int n. This is the value whose factorial I am supposed to find. I am asking you people to enter the factorial of a given number there. So I am going to enter that value. So soon after entering that, I'll check whether the n is less than 0. Because if n is less than 0, I am unable to find the factorial of the given number there. Only positive number factorial we are able to find. Okay, so now that's why, so we'll not be going ahead with the negative numbers here. Okay, and we know that even 0th factorial is also 1 there. 1 factorial is also 1, 0th factorial is also 1 there. Okay, so if the number given is less than 0, we are unable to find the factorial of a negative number there. Okay, I'll simply say it's a negative number, so we cannot find the factorial of that. Okay, I'm just returning from the main there, right? Okay, so if it is whatever number you have given it, if it is a positive number, then what I'm going to do, I'm going to pass this. This is nothing but the actual parameter that I'm passing here. So this is nothing but the actual parameter that I am passing. Whatever value you have read here, the same value I am passing here to this particular factorial function. And I know that it is going to return an integer value. That's why I have written or I have declared this result as integer here. Right? And the data type of this should be equivalent to the data type of the return type of the function here. If there is a mismatch, it's going to throw an error to you all. Right? I hope you know this, okay, because I have mentioned it many times. Okay, so now let's go ahead with the factorial function. Okay, so how it is going to do now? It is whatever n value I have passed here. So I'm checking whether it is n equal to 0 or what. N is 0th factorial is always, any one of you, factorial of 0 is
0.
Hello. Factorial of 0 is?
0.
Is it 0?
Yes,
1.
ma'am.
1. Factorial of 0 is always 1. Okay. So it is going to return 1 back to the calling function. So result is 1 means the factorial of 0 is 1 here. And I'm going to print the same thing. Okay, but whatever value I have entered is not 0. If it is 1. If it is 1. Okay, so in that case, what it has to return? If it is 1, n is 1. What is 1 factorial?
1, ma'am.
1, right? Okay, so now look at this. So what I'm going to do, okay, if it is other than 0, right, if it is greater than 0, then I'm going to calculate the factorial. And I know that, so this product itself is acting as a factorial over here. So product is equal to 1 and I'm taking int as I. Whatever for loop I have written there, the same for loop I am going to write for you all now. Okay, look at this. So I'll show it to you. Now for I is equal to n, I greater than or equal to 1, I minus minus. Whatever for loop I have told you when I started with this, okay, that is without using the user defined function there, the same thing I have written, but it was written in the main function itself. But I am writing this now inside the user defined function here. Okay, I hope I am making it clear. So how do I write? Product is equal to product into I, right? So product is equal to product into I, or fact is equal to fact into I. Fact is initialized to 1, the same thing that I have quoted here. Okay, so now it is going to find the factorial of that particular number, right? So whatever number you have given here, it's going to find the factorial of that number and it is going to return that to the calling function, and which is going to be dumped into result here. So if you send 1 here, so it is not equal to 0, it is coming to else part here, and what it is going to do, I is initialized to 1 here. Okay, so 1 is still greater than or equal to 1, so I'll be inside this. Product is equal to product into I. So product is 1 here, I is also 1. So 1 into 1 is what? What is the new value of product? What is the new value of product? If product is 1, I is also 1. 1 into 1 is? One into one is? Hello? What is 1 into 1, students?
1.
1, right? So product is 1. Then again it is coming back here. So this has become 0 now because I minus minus. I is initially 1, now it is 0. So is 0 is greater than or equal to 1? Is 0 is greater than or equal to 1? Is it true?
No.
No. So I should come out of the for loop. Then what it is doing? It is returning a product. What is product value? What is product value?
1.
1. So it is going to return 1 back to the calling function. So result is going to hold 1 here. So I have sent the 1 as the parameter, or whose factorial I am supposed to find is 1 here, and it is giving me the result of that as 1, which is sent back to the calling function. So this is the function which has called this particular factorial here, factorial function here, and it is returning this value back to this calling function. So result is 1 and I am going to print the same thing here. So whatever value you wanted to pass here, n value, so it's capable of finding the factorial of that number. And that value will be returned back to the calling function. You take any value, so it's going to work for that. So let me take n is equal to something like 4. It's not less than 0, so I'll go to the else part. So I'm going to call this factorial, so by passing 4. What is the value of n here? What is the value of n here?
4.
4, right? So is it equal to 0? Is n is equal to 0?
No, ma'am.
No, right? Okay, so what should I do now? So I go to what we call it as the else part. Okay, so it is product is equal to 1 now. I is equal to n. N is what?
4.
N is what? 4. Okay, is 4 is greater than or equal to 1?
Yes, true.
Yes, it is true. Then what should I do? So I have to find product is equal to product into I. So product is 1 here, I is 4. What is the value of new value of product there? What is the new value of product? 4. Correct? So new value of product is 4. Right? Okay. So again come back, decrement the value of I. I has become 3 now. So 3. Is 3 is greater than or equal to 1? Is 3 is equal to greater than or equal to 1?
Yes, ma'am.
Yes. So again I'll be inside the loop now. Now again it is going to calculate product into I. What is new value of product?
3.
Product value.
4.
4. Right? So 4 into what is the value of I?
3, ma'am.
3. So what is the new value of product now?
12.
12. Correct? Next, you decrement the value of this. So this is 2 now. Is 2 is greater than or equal to 1?
Yes, ma'am, true.
Yes. Again I am entering into the loop. Again I have to calculate product is equal to product into I. So what is the new value of product now?
12.
12. What is the new value of I?
2.
2. So what is the new value of product now?
24.
24. Right? So again come back here. You decrement the value of this. Now it is 1. Is 1 is greater than or equal to 1?
Yes, ma'am, true.
Yes. Okay. Product is equal to product into I. What is the new value of product now?
24.
24. What is the new value of I?
1.
1. So what is the new value of product now?
24.
24. Right? Again you decrement this value, I value. So is 0 is greater than or equal to 1?
No, ma'am, false.
False. What should I do?
Exit the loop.
Exit the loop and return the product. What is the product final product value here?
24.
24. What it is returning into the result here?
24.
24. Is 4 factorial is 24?
Yes, ma'am.
Right? So what you are going to print now? The factorial of 4 is 24. Is it right?
Yes, ma'am.
So are you getting what I am trying to convey here? Understood? Have you understood this concept? Is it okay? Any doubt regarding this, students? Say something. Understood? Understood? Yes or no?
Yes, ma'am.
Okay. So now I'll take the same thing. So we'll try to write the recursion for this. Okay, the same thing, right? Okay, so I need two things. One for writing the or one particular stuff that is helping me to call itself, which is dependent on the problem definition there, and I need one more stuff as the conditional, that is the trivial condition, termination condition, right? So let's look into the same thing now. Right, now look at this. So now to find the factorial of this, okay. So I mentioned n factorial can be written as n into n minus 1 factorial, correct now? N factorial can be written as n into n minus 1 factorial. Is it true?
Yes, ma'am.
Right. So this is factorial. This is going to call another factorial. Is it n minus 1 factorial? Is it n minus 1 factorial? Correct now?
Yes, ma'am.
This is also factorial. This is also factorial. Is this factorial is calling this particular factorial here? If I write equation like this, n factorial is equal to n into n minus 1 factorial, is this factorial is calling this particular factorial function here? Do you agree for this? Say something.
Yes, ma'am.
Right, this is factorial, and in the equation I have written one more factorial. To get this factorial, I have to call this factorial. Right, so this can be again expanded something like n minus 1 into n minus 2 factorial. Right, is this n minus 1 factorial is calling another function called as n minus 2 factorial here?
Yes, ma'am.
Right, so is it calling, is this particular factorial is calling itself here, factorial, another factorial function here? Do you agree for this or no? Say something.
Yes, ma'am.
This is factorial, this factorial is calling itself, this factorial is again calling itself. If I write again one more stuff for this, n minus 2 into n minus 3 factorial, so this factorial is calling one more factorial. You go on writing this, so that factorial is going to call itself. How many times? Until a base condition is satisfied. This is my base condition, this is my trivial condition or termination condition. So this termination condition is very important for me along with this particular recursive function. Is it okay? Is it okay? Is it okay? Say something.
Yes, ma'am.
Right. So if n is equal to 0, I am going to return 1 because I know that factorial of 0 is 1. Right? I already mentioned, no, if n is equal to 0, factorial of 0 is 1. So it has to return 1. This is my termination condition. If n is greater than 0, then what it has to do? It has to find the factorial. But how do I find that? Using a recursion. For that, what I need to do? The function called factorial has to call itself. Correct? So this particular factorial has to call itself. How many times? Until this particular condition is met. Is it okay now? Say something. Understood,
Yes,
student? Right. Okay, now look at the simple example that I have quoted here. 5 factorial. How do I write that 5 factorial? 5 into 4 factorial. Is it agreeable? You have to give response faster. 5 factorial can be written as 5 into 4 factorial. It is agreeable. Is it agreeable?
Yes, ma'am.
Right. Now 4 factorial can be written as 4 into 3 factorial.
Yes, ma'am.
So 3 factorial can be written as 3 into 2 factorial here.
Yes, ma'am.
So 2 factorial can be written as 2 into 1 factorial here. So 1 factorial can be written as 1 into 0 factorial here. And once 0 factorial is reached here, okay, you know that once 0 factorial is reached here, so this is my termination condition. I should traverse back. So I have to come back like this. So I know that this is 0 factorial. 0 factorial is 1. This is my termination condition. I shouldn't call one more factorial there. This becomes the termination condition for me. So I have to reverse back. I have to traverse back. How do I traverse? I know that this 0th factorial is adding or giving a value as 1 factorial. So 1 into 1 is giving me 1 again. So this is nothing but my 1 factorial. So I am going to place this 1 factorial value inside here. So this is 2 into 1 giving me 2 here. Then come back here. So this gives me 2 factorial here. So 3 into 2 factorial is nothing but my result is 2 here. It's giving me 6 here. So this is nothing but my 3 factorial. 3 factorial is 6. So 6 is coming here. 6 into 4. So 6 into 4 is 24. So 24 is my 4 factorial. So it is written back to this here. 5 into 24 is nothing but how much? Is it 120? Is it 120? Yes.
Yes,
So
ma'am.
is this 5 factorial is 120 here? Is it okay, students? Say something. Is this okay? This is how the recursion works. And this is taken care by your system. But you need to know the procedure, but you have to write only 2-line codes for this, not more than that. You need to know the function which helps me to call itself, and I need to know the terminal condition for this. If you know this much, but you need to know how that works. This is how it works. That's what I am conveying here. So look at the same stuff I have written. This is the first time that is called by the main function. Now this is how it is calling itself. This factorial is calling this 3 factorial, this 3 factorial is calling this is calling this is calling this. And this is finally becoming the termination condition for me. Then it will start returning back to the main function here. It is traversing back. Is it okay, students? Is it okay?
Yes, ma'am.
Right. Okay, so now you have to concentrate more to understand this. That's what I'm trying to convey here. Right? Okay, this is very important fact. You have not understood anything. Please don't hesitate. You ask any questions you have in your mind. So I said that we need to have the recursive function. This is my recursive function. So this is what is the recursive function. And this is my termination condition. I have to have these two things properly, then only I am able to find the recursion. I am able to give the solution using a recursion. Clear? Is it okay, students? Shall we move towards the program now? Oh, so let's look into this now. So now we are going to find the factorial of a given number using recursion. Okay, using recursive method. So I try to explain you without using functions, with using functions, now with using the recursive. Right? This is the stuff. So look at this. stdio.h. Again, I have to have the same function, whatever I have mentioned there, because this recursion is also a function itself, but little modified kind of stuff. So int. So this is the same thing what you have mentioned for the, what we call it as user defined function there. So I'm asking you people to enter the number to whose factorial you are supposed to find. I'm entering that. Okay, if it is less than 0, I'm unable to find the factorial of a given number there. Else, I'm able to call the function here. So first time I'm calling this. Afterwards, this particular function has to call itself until I get the factorial of the given number there. Alright, so once I get that will be sent back to the result here that I'm going to print here. So now how do I write this recursion? Let's look into the same thing now. So now this is called here, right? So whatever value you are passing here, so now look at this. If n is equal to 0, because this is my termination condition. Please remember, this is my termination condition. Look at the termination condition that I have written. This is my termination condition. If n is equal to 0, I have to return 1. This is my termination condition. Else, it has to do, that is, it has to return n into factorial of n minus 1. Same thing I am writing now. I am not changing anything there. If n is equal to 0, it is returning 1 here. Else, what it has to do? What it has to do? Else means n is greater than 0, because once I entered here, if n is greater than 0. Otherwise, I am not entering into the particular function here. What I have to return? Return. Yes. I need your response, students. Return. Hello. What you have to return? I've shown you everything in the previous slide. If n is equal to 0, you have to return 1. Else, if n is greater than 0, what you have to return? Any one of you students who have carefully watched the previous video? Previous slide? Any one of you? Yes, any one of you? If you pardon?
Product.
Product. Where is the product? Can you see the product here in the previous slide? What I have written? What it is returning here? Hmm? What it is returning? I have to write a function which has to call itself. If n is equal to 0, it is returning 1. If n is greater than 0, it has to return what? What it has to return? This is the recursive function that I have already mentioned. N into n minus 1 factorial. This is what it has to return. So I'll be writing this as n into fact of, written it as capital fact, you write it as capital fact into n minus 1. So this is how it is going to work. Now look at this. This is the same thing that I have written. Is it okay, students? This is the simplest program that you people can write to find the factorial of a given number. I already told you. So recursion functions are very easy. Okay, only 2-line code. This is the 2-line code. But if you go ahead with the function that you have written just previously, okay, so now if you look at the things that you have written using this, now look at this. This much of code was there. Okay, so now look at this. This much of code was there to find the factorial of a given number without using a recursive method. But if you use a recursion method, now look at this. Only this much line of code. If and this is the termination condition, this is the particular function which helps me to call itself. Is it okay, students? This you have to practice. This you have to find it out. So this purely depends on what is the problem statement you are carrying out. Is it okay, students?
Yes.
Right? Okay. So now I'll try to analyze this. Okay. So now you have to give the support to me, then only I can do that. Okay. If you are with me and if you are able to answer for the stuff there, then I'll try to explain this. Are you there with me, students?
Yes, ma'am.
Right. Okay. I need a blanks. Okay. Blank screen I want. Go to the slide. Screen blank. Okay, white screen. So what is the function, that fact function that we have written? Fact function. I told you I need your support. Without your support, I cannot do anything, students. I need your support. I have to remember that. Okay, so you have to tell me about this. I'll try to explain this. Okay, this particular function you explain me. Okay, so I'm explaining the same thing now. You remember this? Do you remember these things? Okay, so let's go ahead with that. Oh no, not again. White screen I need. Okay, tell me. Fact. So it is going to int fact. Int fact. Int n. Correct now? Is it okay, students? If n is equal to 0, then I have to return 1. Correct? Else, So if you don't interact with me, so there is no point in teaching this concept to you all. Students. Hello, are you there, students? Hello. Hello. Okay, so let it be. So there is no point in talking with the dummy machines. I already mentioned that. So I'll be sending 4 here. Okay, this has come from the main function. So this is 4 that I have taken. I'll check for this. Is 4 is equal to 0? No, it is not 0. So I'll go to the else part here. So this is my 4 here. I'll keep this 4 as it is, right? So this I'm going to call itself. What I'm going to call the same function, because fact, it is calling me the fact. So I have to call the same function here. Fact n minus 1. I'll try to rewrite this. Okay, fact of n. Okay, so this is int n, and let me write it as int n. So inside this I'll be writing n is equal to 0, return 1. Okay, else return, so n into fact of n minus 1. Okay, all right. So now this is what it is sending me. It is sending me 3. Okay, it is calling itself instead of dumping everything inside the same stuff. So I've just rewritten this over here. Okay, the same program I've copied here. So it is coming over here, and this is now 3 here. So this is 3. 3 is not equal to 0. I'm going to else part here. This is my 3 here, and this is my 2 here. And again, I have to call the same function by passing this particular stuff. I'll write it here for you all again. Fact int is equal to fact of int of n into bracket if n is equal to 0, return, okay, 1. Okay, then else return n into fact of n minus 1. So look at this. This is what I'm sending. I'm sending here 2. So 2 is not equal to 0 here. So I'll go to else part here. This is my 2. 2 here. So fact of n minus 1. N minus 1 is 1 now. So again it is calling the same function. I'll rewrite this. So this has to call. Okay, now this is one more time I'm writing. Okay, so now see how the system works. How many times it is calling itself. Okay, until the particular termination condition is met, it has to call itself. So this is how the system works. Else, I'll call return, okay, n into fact of n minus 1. So this I'm sending here. Where is that? Okay, this is here. So this is what I'm passing here, right? This is 1. So 1 is not equal to 0 here. So that's why it is going to else part. This is my 1 here. So this has become 0. Now again I have to call this factorial now. I'll write that, rewrite for you all. Int fact of n. So if into bracket if n is equal to 0, right? Okay, return 1, else return n into fact of n minus 1. Okay, so now whatever value I've sent is here now. This is 0 here. So is n is equal to 0 now, students? Yes, say something. Hello? Is n is equal to 0 here?
Yes, ma'am.
Yes, if it is n equal to 0, am I going to else part here?
No, ma'am.
No. Am I calling this function again here? Am I calling this? No. Means I have stopped calling itself because I have met with the termination condition. Now this has 0 now. N is equal to 0. 0 equal to 0. It is going to return 1 back to the calling function. Who has called this function? This particular stuff has called this particular function. That's why it is returning 1 back to this particular factorial. So this is 1 into this is 1. This is nothing but 0th factorial. So this gave me the 0th factorial. 0th factorial is 1 here. So 1 into 1. So this is called by, which this particular stuff is called by this particular function here. That's why this particular 1 into 1 value is written back to this particular factorial. So this is nothing but 1 here. So this is 2 into 1 here. So now look at this, 2 into 1 is nothing but 2 here. So this particular function is called by this particular function. So that's why this particular 2 value will be returned to this particular factorial. This is 2 now. So 3 into 2 now. So this is 6. This is called by this particular function here. Okay. So that's why it is coming back to this, and it is replacing this particular n, that is factorial of 3 here. So factorial of 3 is given me, this value is 6 here. So this value is 6 here. So 6 into 4 is nothing but 24. The whole stuff is 24. This is returned back to the calling function where you have something called as result in the main function. This is how the recursion works. Are you clear with this, students? So this is exactly how the system is going to carry out the recursion. Is it okay? The function is going to call itself. The function is going to call itself. Again, I have written the same thing here. I'm not changed anything. Okay, because any modification I cannot show in the same function. That's why I have written these many times. That's all. Okay, because every time doing the modification is little harder for me. Okay, so I've just shown you how it is going to call itself and how it is going to dump those things inside the memory. Is it okay, students? Say something. This is how exactly the recursion works, right? And I already mentioned that if you just go through once the data structure syllabus, okay, you have so many functions that recursion. Okay, so I think 5 to 6 programs are there. I'm not 6, maybe 6, 8, 10 programs may be there on the recursion in the data structures. But the working of that purely depends on this. Okay, tower of NOI problem is there. There are a variety of problems. Everything is solved by only, some of the problems are usually solved by only the recursion functions. Even you people can work on the, the searching techniques, sorting techniques using this particular recursion. Okay, for that you should be able to write the termination condition. You should be able to write the recursive function there. Okay. So I hope I made it clear to everybody. Is it clear, students? Is it clear, students? Right. So in the next class, I'll take up one more example. Okay. So today we dealt with what we call it as factorial of a given number. So tomorrow I'll be dealing with, okay, so in the next class, I'll be dealing with the, okay, finding the Fibonacci series, right? Okay. So I'll try to explain again all using 3 methods. One is without using the functions. Next one with using the normal functions, with using the recursion function. Okay, for that I already told you people, your support is must for me. Is it clear, students?
Yes, ma'am.
Right, okay. So have any doubts, you people can ask me before I close today's session. If you have any doubts, please don't hesitate to ask the questions. Feel free to ask the questions.